Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for a little bit more exam revision with the Batty Boffin. Today we're looking at quadratics and we are being helped as ever by Bathilda the Batty cat. Now when I say helping, I mean this in the usual way that cats help, as in sitting right in the middle of the most important thing, and there she is, she's sat on my quadratic equation. So I can't actually tell what it is. It's 3x squared plus something x minus 10 equals 0. Now I do know that one of the solutions is that x equals -5. So for part A of this question, you need to find out what number Bathilda is sitting on. And for part B, you need to finish solving the quadratic equation, find the other solution. No problem at all. Here's one of those kind of pause things while you have a bit of time to solve it, and I'll see you in a minute. Right, let's go through that together. The first thing we're going to have to do is get our quadratic equation. So what I'm going to do is write it all out, substituting in -5 instead of x, and I'm going to put a b, as in ax squared plus bx plus c, and put a b where Bathilda's bum is. Yes, I said the word bum in a maths video. And then hopefully we should see it all comes out after that. So writing it out and substituting in, we've got 3 lots of, and instead of x squared, I'm going to put -5 squared, plus b lots of -5, that's for my x, minus 10 equals 0. Okay, simplifying all down here, -5 squared, please, is +25, yes? So 3 lots of 25, that is 75, minus 5b, just writing those the other way around, minus 10 equals 0. Getting all this lot together, we have 65 minus 5b equals 0. Actually, I'm going to add 5b to both sides on there, makes it a little bit nicer. We get 65 equals 5b. Dividing both sides by 5, we get 13 equals b. So b, the missing number, is 13. So what I'm going to do now is write out my equation again, but substituting 13 for Bathilda's cute little bottom. Right, so there's our quadratic. Now we need to solve that. We've got one of the solutions, and we're just going to do the other one. Now you could use the formula for it, but I'm actually going to factorise it. Factorising things when you've got a number in front of the x. Now some of them can be quite complicated, but this one's actually going to be dead easy because the only way of factorising that 3 is into a 1 and a 3. So for our brackets, we know that one of the brackets has to be 3x, and the other bracket has to be x. Okay, equals 0. For the numbers at the end, we know that those two numbers have to multiply to make -10. That's the same as ever. But instead of adding to make 13, they've got to add to make 13 when one of them is trebled. So let's start off, as always, by just listing out the combinations that make -10. So we could have a 1 and a -10, or a -1 and a 10, a 2 and a -5, or a -2 and a 5, and that's the only ways of making -10. So just having a look, things that make 13 when you treble one of them. Well, having a look on here, you might think, ah yes, 10 and the 1. If you treble the 1, you get a 3, and the 10 makes a 10. You think, oh yeah, 10 and 3, that's 13. Yeah, but see, it's positive and one of these is negative. So that's actually not going to quite work. What we can do is use these ones down here. We're going to be using a 2 and a 5. Okay, so let's see if we can work out how to do this. If we treble the 5, we'll get a 15. And taking away the 2 gives us a 13. You see, it's the difference in signs. If they were added up, we could use the 1 and the 10, but they're actually going to be taken away because one of them's negative. We need a positive 13, so it's going to be that one, so that that 5 can make a positive 15. In order for the 5 to be times by the 3, the 5 has to be here. So we get a 3 times a 5, which makes a positive 15, and then we put the -2 in there, so that we get a 1 times a -2 is a -2. Quick check here. First 2, 3x squared. Outside 2, 15x. The inside 2, negative 2x, making a total of 13x, and the last two, negative 10. If you are not sure how to do this, check out some of the other Batty boffin videos where we do that kind of thing. But having factorised it there, we can now get our solutions. What we can do, if you say this bracket times this bracket equals 0, then either that bracket must have been 0 or that bracket must have been 0. This one here, if we say that x plus 5 was equal to 0, then this implies that x must have been negative 5, which indeed is the solution we had earlier. The other one, if we say that 3x minus 2 was 0, this implies that 3x must have been equal to 2. In other words, x was equal to 2/3. And that's the other solution. Okay, there we go. Bathilda the Batty cat, who sat right in the middle of my quadratic equation, has now obviously wandered off to go and sit in a nice sunny spot, because now that I don't need it anymore, she's obviously gone. And I will see you next time for a little bit more maths. See you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!